Hello and welcome to the Science of Everything channel. Tonight, we turn our gaze toward humanity's oldest companion in the story of our species, the full moon. This is not merely an astronomical observation. It is a walk across time and space, a shared exploration of deep space and the human soul. For thousands of years, people have stepped outside under bright nights to feel that same quiet awe. Imagine, in the ancient wilderness, as the last blush of sunset vanished behind the ridge and the world plunged into pure darkness, suddenly, a pale globe hung suspended in the blackness above, like an eternal, solitary lantern illuminating sleeping fields and silent rooftops. It rises as the sun slips quietly below the horizon. For some reason, it always feels both familiar and mysterious. Its light is not the aggressive, scorching heat of the sun, but a cool, clear, almost cruelly bright glow. It allows us to recognize distant trees at night, guides travelers home, and fills poets with inexplicable melancholy. However, if you think the full moon is merely a beautiful landscape, you are underestimating it. Strip away its romantic veneer, and it is a moving world of rock and dust, reflecting sunlight from hundreds of thousands of miles away. It has no atmosphere, no breath of life, a dead, desolate wasteland. Yet it is not indifferent. It shapes our world in ways we cannot touch. Its invisible hand of gravity tirelessly sculpts the ocean tides, making coastlines breathe with the ebb and flow. Before electricity softened the night, it was the only beacon guiding calendars, festivals, and journeys. Its light alters animal behavior, inspires myths in every culture, and reveals clues about the deep history of the solar system. So tonight, we will wander through science, history, and the astonishing secrets hidden behind that bright circle. If you enjoy this gentle journey of discovery, please like, subscribe, or leave a comment below. It helps other weary souls find their way here, one by one. But for now, just settle in. Let your body relax and your eyes grow heavy. As the daylight slowly drifts away, join me in exploring the full moon. Let us begin. The first thing we must understand is perhaps a little cruel. The full moon is never truly full for more than an instant. We tend to think that bright face is stable and complete all night, like an ever-burning light bulb. But that perfect geometric alignment is fleeting. The moon is constantly moving through space, and so is Earth. Thus, only at that precise moment is the side facing us fully illuminated. Before that, a sliver is missing. After that, the opposite side is missing. Our naked eyes barely perceive this change because the difference is so minute. Like watching the second hand of a clock. It seems to linger at 12, yet it only pauses for a fraction of a second. Astronomers know this secret, and it makes the event more interesting, not less. What seems stationary is actually a single frame in a motion picture. It is like trying to capture the exact moment a spinning dancer's arms are widest apart. You might think you see eternity, but what you are seeing is timing, the millisecond the cosmic shutter clicks. This movement creates striking visual effects, especially at moonrise. When the full moon rises, the sun is setting on the opposite horizon. It is one of the most elegant arrangements in the sky. As the day's last golden glow fades in the west, the bright moon appears in the east, as if one giant lamp is taking over for another. Those unfamiliar with the stars are often surprised, thinking the moon can appear anywhere, anytime, like a whimsical sprite. In reality, that round face follows a beautiful logic. From our perspective, the moon is positioned directly opposite the sun. That is why sunset and moonrise are partners. If you stand somewhere with a wide view, a beach, a plain, a mountain, you can sometimes witness this handover in real time. One side of the world bathes in the last gold of day, while the other welcomes a pale orb climbing into the darkness. It feels theatrical, but it is just geometry. The drama comes from Earth's rotation, from sitting on this spinning sphere as the stage lights come up on the opposite side. When you stare at the lunar surface, what do you see? Is it the legendary jade rabbit, or Wu Gang chopping the laurel tree? In truth, those familiar dark patches are ancient lava plains. Those broad, charcoal-colored areas were once called Maria, meaning seas, because early observers thought they were vast bodies of water. When Galileo peered at the moon through his crude telescope, he too thought the dark areas were oceans, naming them after seas on Earth. The old names stuck, so we still hear terms like the Sea of Tranquility or the Ocean of Storms, even though not a drop of liquid water exists there. Actually, those darker regions are massive basalt plains formed by molten rock flooding into low-lying areas after giant impacts tore open the planet's crust. This means the dark spots most people recognize with the naked eye are the cooled remnants of ancient volcanic activity. They are not merely stains on the surface. They are evidence that the moon was once far more active than it appears today. This changes the meaning of the full moon. Those dark patterns are not decorations. They are frozen lava landscapes scattered across an airless world. Every time we look up and recognize them, we are seeing the fires of the moon's distant past. Interestingly, human perception of the full moon is full of illusions. The moon looks gigantic near the horizon, but this is just a visual trick. It is one of the most famous deceptions in the sky. When the moon first appears above distant trees, rooftops, or hills, it looks so large you might stop to wonder if some celestial disaster is imminent. People often assume the atmosphere magnifies it like a lens. It does not. In fact, because Earth is a sphere, the moon on the horizon is actually dozens of kilometers farther away from us than when it is overhead, making it visually slightly smaller. The real change happens in your perception. When the moon is low, your brain compares it to familiar earthly objects. Chimneys, fields, towers, and roads provide a sense of scale. In the high sky, that comparison vanishes, and the same moon looks smaller. This reminds us that viewing is never passive. The brain is always interpreting. It makes the experience more fascinating. The giant horizon moon is a collaboration between astronomy and human psychology. The sky provides the object. Your brain quietly constructs the grandeur. This perceptual bias makes the moon feel close. Indeed, the full moon feels near, hanging right above our heads, within arm's reach. But it is roughly 250,000 miles away. This tension between intimacy and distance is part of its magic. The moon looks large enough to be a companion. It rises over your neighborhood, shining on your roof, your trees, your street. Yet, by daily standards, it is staggeringly far away. Cars, ships, and planes are useless comparisons. Even light, the fastest thing we know, takes just over a second to cross that distance. Humanity only crossed that gulf within living memory, and it still feels unbelievable. When astronauts looked back, they saw Earth hanging in the black vacuum of space, and the moon beneath their feet was no longer a symbol but a real world of dust and rock. This is the wonder of seeing the full moon from Earth. Emotionally, it belongs to an ordinary night. Physically, it is another world entirely. It teaches distance in a strange, gentle way. Some things can feel close in your heart while being physically vast, remote, and almost unimaginable. Moreover, we always see the same face of the moon. Every full moon shows us the face Earth has known for millennia. From the ground, we never see the far side of the moon because the moon's rotation period is exactly the same as its orbital period around Earth. This keeps one face permanently turned toward us. So when the disk becomes full, those familiar patterns of dark plains and bright highlands are identical to what people saw thousands of years ago. Ancient farmers saw it, sailors saw it, poets, emperors, shepherds, and children all saw it. Entire civilizations built stories around that eternal face. Some cultures saw a rabbit, some saw a man, others saw a toad, a woman, or a bundle of firewood. Modern spacecraft later revealed the hidden far side, but the face we know remains the moon's public display. This continuity is moving. Human history has become unrecognizable, yet the same lunar features return above us. The world below changes, the face above remains, waiting to be recognized again. This stability is born of gravity, but also constrained by it. The full moon pulls the ocean tides from afar. The moon seems distant and serene, yet gravity bridges that gap effortlessly. Its pull does not just lift the water in one spot, it creates bulges in Earth's oceans. As our planet rotates, coastlines pass through these bulges, experiencing tides. During the full moon phase, the sun, Earth, and moon align in a straight line, combining the gravitational forces of the moon and sun into a stronger pull. The result is a set of particularly pronounced tides known as spring tides. This has nothing to do with the season of spring. The word refers to a rising or leaping motion. Ports feel the difference. Mudflats submerge, currents rush faster through narrow channels, and the coastline breathes more heavily. This is one of the most wonderful things about the full moon. It is not just a sight, it is an influence. You can look up at the light and look down at the sea, knowing the same celestial alignment is shaping both. Light reaches your eyes, gravity moves the water. Ancient people understood this power well, using the full moon as a calendar written in light. Long before printed calendars on walls, the sky provided a repeating signal anyone could track. The phases changed night after night, and that bright, full circle became an easy marker for measuring weeks and seasons. Communities remembered when to gather, when to travel, when to hold ceremonies, and when certain natural phenomena usually returned. It required no advanced instruments, only attention. The cycle was visible, reliable, and shared. Children, hunters, or elders could all look up and have a rough idea of where they stood in the month. Over time, full moons acquired names linked to weather, harvests, animals, and seasonal work. These names were not random poetry. They were mnemonic tools connecting survival to rhythm. In this sense, the moon was not just observed, it was read. It provided a luminous accounting system for human life, and many cultures built entire timekeeping systems around its returning brightness. This timekeeping function varies by hemisphere. In the northern hemisphere's winter, the full moon tends to ride higher in the sky. This surprises people because winter is often thought of as a time of low suns and long nights. Yet, it is precisely this geometry that elevates the full moon. When the sun traces a low path across the sky in the northern hemisphere, the point opposite it in the night sky rises higher. Since the full moon appears opposite the sun, it often climbs along a higher arc. This can make the winter moonrise feel exceptionally majestic. The moon clears trees and rooftops decisively, lingering longer in the sky. Its light can spread widely over frost, snow, or bare ground, making the whole season feel brighter. For those living in cold climates, this may be one reason why winter moonlight is so memorable. The night is long enough to contain it, and the moon's path carries it high above the horizon. In the darkest time of year, the sky answers with its brightest, highest nocturnal display. It feels almost like a seasonal gift. In contrast, the summer full moon often stays lower and softer against the horizon. If the winter moon climbs confidently, the northern hemisphere's summer moon often glides along a humbler path. It rises and drifts along a lower trajectory, seeming never to escape the company of trees, hills, and distant buildings for long. That low path changes its character. Warm air near the ground blurs the disk, haze tints it gold or amber. The light feels thicker, more atmospheric, less piercing than in the colder months. It is the same moon, but the seasons alter the performance. This is one of the joys of following it throughout the year. The sky does not present the full moon in a single, standard form. It offers variations. The summer moon may feel slower, heavier, more entangled with the landscape. It lingers in the lower layers of night, where heat, dust, and moisture reshape its appearance. Sometimes, the weather joins in. Thin clouds can turn the full moon into a glowing silver lantern. When wisps of cloud drift across the bright disk, they do not always block it. Sometimes they transform it. Moonlight diffuses through thin vapor, creating a soft, glowing bloom that makes the surrounding sky feel alive. This effect is less like a spotlight and more like a lantern seen through fabric, bright at the center, spreading out into a floating halo of silver light. It is far more atmospheric than a perfectly clear view. The moon ceases to be a sharp object and becomes a luminous presence suspended in the dark. Painters and storytellers have always loved that look because it feels both mundane and transcendent. The cause is simple. Tiny water droplets and ice crystals in the clouds scatter the light and spread it out. Yet the result can stop you in your tracks. The familiar full moon becomes dramatic, and the sky seems to gain depth, softness, and mood in an instant. If there are ice crystals high in the sky, you might see something even more magical. Ice crystals can wrap the full moon in a pale circular halo. High above the ground, thin, icy cirrus clouds fill the sky with countless microscopic ice crystals. When moonlight passes through them, the crystals bend the light in a very specific way, and a wide ring appears around the moon. This halo is usually large, faint, and ghostly white. Though a careful eye might catch a hint of color, it looks so clean and perfect, as if designed rather than natural, like a giant compass drawing a circle in light. The science behind it is beautiful because it relies on shape. Many of these crystals are hexagonal, and their geometry helps produce this ring. So, the halo is not random decoration. It is an optical phenomenon written in the sky by delicate, nearly invisible falling ice. This is part of the marvel. Something exquisite and minuscule high above you can create one of the grandest patterns in the night sky, grand enough to frame the moon itself. This halo can even predict the weather. A bright halo around the full moon can hint at changing weather. For centuries, people noticed that rings around the moon often preceded shifts in the weather. The old saying that a halo means rain is not baseless. Those glowing circles are often caused by thin, high clouds filled with ice crystals, and these clouds frequently trail approaching weather systems. So, while the halo does not guarantee rain, it is a genuine clue that the atmosphere is changing. This makes the sight not just decorative, but informational. Long before satellites and weather maps, people read signs like these with great attention. Because the sky affected travel, harvests, and safety, the moon became part of both wondrous and practical observation. This fusion is satisfying. A beautiful optical effect can also carry useful information. Beauty and warning can arrive together in one bright ring. Regardless of the weather, the color of moonlight itself changes. Some full moons look golden because the light passes through thicker twilight air. When the moon first rises, its light must travel through much more atmosphere than when it is high in the sky. This longer path matters. Along the way, the air, dust, and tiny droplets scatter away more of the short, blue wavelengths, leaving the warmer colors to dominate the light entering your eyes. The result can be a rich, golden moon hanging over fields, rooftops, or distant mountains, looking almost unreal. It has not turned into another world. The change happens in the air between you and it. This is one of the great pleasures of moonrise. The sky can turn a familiar object into a temporary surprise. The pale silver disk you see high in the sky a few hours later may have been amber just an hour before. This shifting color gives the full moon a sense of drama. It reminds us that looking at the moon is never just about the moon itself. Earth's atmosphere is always part of the show, shaping the light before it arrives. If the moon is lower, the color turns redder. The red full moon near the horizon owes its color to Earth's atmosphere. The deeper the moon sits at a low angle, the more air its light must traverse before reaching you. This journey filters out more short waves, allowing the red tones to survive. The same basic process explains spectacular sunsets. In both cases, the atmosphere acts not like empty space, but like a filter. Smoke, dust, humidity, or pollution can intensify this effect, pushing the color from warm gold to copper, even to a striking reddish orange. This can make the rising moon look dramatically intense, even ominous, explaining why the red moon has long fired the human imagination. However, the cause is not supernatural. It is physical, local, and entirely understandable. You are not seeing the moon change its nature. You are seeing our own planet alter the light with the color of the air around us. At that moment, Earth becomes part of the picture, painting the moon with the hues of our surrounding atmosphere. Beyond color, clarity is also subject to the atmosphere. In cold air, the full moon often looks sharper than in humid air. Anyone who stargazes across seasons can feel this difference. On crisp winter nights, the moon seems etched into the darkness with startling precision. The patterns of craters look cleaner, the edge of the disk looks harder, more definite. In warm, damp conditions, that same bright face might look softer or slightly blurred, as if viewed through a veil of gauze. Moisture in the air scatters and smears the light. Turbulent layers make details shimmer or dance. Cold air is not always perfectly stable, but it is usually clearer and drier, which helps the moon stand out with higher clarity. This is why bright winter nights feel so memorable. The world is darker, the air bites, and the sky seems to reveal itself with extra honesty. You are still gazing across hundreds of thousands of miles of space, but the difference between clarity and blur may depend solely on the state of the air just above your skin. Atmospheric interference can even make the moon look like it is dancing. Near the horizon, the full moon can ripple like a mirage in the heat. When the moon is low, its light passes through thick layers of atmosphere filled with moving pockets of warm and cold air. Those moving layers bend the light slightly in different ways, causing the moon's edge to tremble, ripple, or blur. Above hot ground, roads, rooftops, or desert air, this effect can be particularly striking. The moon may seem to shake, as if reflected in water. It can flatten, stretch, or flicker at the edges. This is the same type of atmospheric distortion that causes terrestrial mirages. It reminds us that the horizon is one of the most dynamic places to watch the moon. The low-hanging full moon is never just the moon. It is the moon filtered through the turbulent lower atmosphere of our own planet. This is why moonrise feels so vivid. The sky is not displaying a static image. It is showing a world through moving air. Atmospheric turbulence can make the full moon ripple, sway, or flash with color. Even on a clear night, the air above us is not still. It is filled with moving layers of different temperatures and densities. Each layer bends light slightly differently. When the full moon's light passes through that turbulent air, the bright disk may appear to quiver, wrinkle, or dance at the edges. Sometimes the effect is gentle, sometimes it is dramatic, making the moon look almost liquid. Under stronger turbulence, tiny flashes of color may appear along the edges as the atmosphere briefly splits the light into different hues. This is especially noticeable when the moon is low, but it happens high in the sky too. The sight feels strange because it reminds us the sky is not an empty window. We are always looking through an ocean of moving air. The moon itself remains still in space. The trembling belongs to our atmosphere, turning a solid world into a wavering image, and that is all. All these atmospheric tricks mask one fact. The full moon does not shine on its own. It only reflects the sun's light. It is easy to talk about the moon glowing, but that word is misleading. The moon is not a light bulb nor a star. It produces no visible light of its own. Everything you see on a bright moonlit night is borrowed sunlight that struck the moon and bounced back to Earth. This means moonlight is second-hand brilliance. Its journey begins at the sun, reaches the dust-covered lunar surface, and only then continues toward us. There is something beautiful in that chain. The light spilling over a sleeping town has touched another world. Before it entered your eyes, it was reflected off ancient rocks and impact plains. This also explains why the moon has phases. As the geometry changes, we see different portions of that half which is illuminated. So the moment of the full moon is when that borrowed light is presented to us most completely. The moon appears self-sufficient in the sky, but its light is actually an act of elegant dependence. Its beauty begins with the sun. Why can the moon reflect so much light? Because the material on its surface is special. The full moon is bright because rough dust reflects light intensely. At first glance, you might think a smoother surface would shine brighter. On Earth, polished things are usually the shiniest. The moon does something more interesting. Its surface is covered in fine, broken material called regolith, formed by billions of years of impacts grinding rock into dust and fragments. That rough surface scatters sunlight in many directions. And near the full moon phase, it reflects a surprising amount of light back toward the source, which is our direction. The result is a steep rise in brightness as the geometry becomes just right. This means the moon's glow is connected to violence preserved over immense time. Every collision that helped grind the surface also helped shape how it reflects light today. So when the complete disk shines with unusual intensity, you are seeing the optical consequence of a moon that has been battered for billions of years. Beauty does not ignore scars. In a way, it is because of them. The moon shines so brightly because it has been shattered for eons. This change in brightness is not linear. Around the full moon, the brightness of the lunar surface surges suddenly. This may be subtle to the casual eye, but instruments can measure it clearly. As the moon approaches the precise geometry of the full phase, its brightness rises more steeply than a simple, smooth trend would predict. In other words, the moon does not just get steadily brighter night after night and then reverse. It gets a final boost right near the full phase. This surprise is one reason planetary scientists pay close attention to how airless worlds reflect light. This effect reveals information about the texture and structure of the surface. It also helps explain why the full moon phase feels strikingly intense compared to the nights before or after. Our nearest neighbor is not just brightly lit. It is responding to the alignment in a special way, bouncing back more light than expected. This adds an extra layer of drama to the full moon stage. That familiar bright disk hides a delicate optical trick, turning a gradual cycle into a small climax at the peak. This brightness surge is called the opposition effect by planetary scientists. The name sounds technical, but the idea is elegant. It occurs when the sun, the moon, and the observer line up so that the light comes almost directly from behind the observer. In this alignment, the tiny shadows cast by particles on the lunar surface are hidden from view, making the ground appear brighter. There may also be an extra boost from light waves reinforcing each other as they scatter back along nearly the same path. Together, these effects cause the sudden brightness increase near the full moon. Scientists study this not just for the moon, but for asteroids and other airless bodies, as it provides clues about surface texture and composition. So, a beautifully bright full moon is also a laboratory result displayed in the sky. The light that delights the casual observer is transmitting information. It tells us that even dust can have complex optical behavior, and that light itself can reveal the texture of distant worlds. Although the full moon is blindingly bright, it reveals very few details. The full moon reveals fewer deep shadows than the crescent moon. The crescent moon, viewed through a telescope, can be incredibly dramatic because the boundary between day and night cuts across mountains and crater walls, casting long, black shadows that carve the surface into sharp relief. By the time the disk is full, much of that drama softens. The light falls more directly, and many of those deep, dark pockets shrink or vanish from our view. For someone observing the moon in detail for the first time, this feels almost upside down. You might expect the brightest phase to reveal the most texture, but instead, it conceals some of the strongest contrasts. This teaches us a beautiful lesson about viewing. Brightness alone is not enough to reveal shape. Shadows do most of the work. Remove them, and the land can look calmer, broader, less rugged. So the full moon phase offers a different kind of beauty. It trades a jagged, dramatic face for an open, serene one. And that face has captivated humanity for ages. Specifically, at full moon, craters look flatter because sunlight hits them head-on. The moon is covered in bowl-shaped depressions, basins, rims, terraces, and high walls uplifted by ancient impacts. Yet, during the brightest phase, many of these features lose some of their apparent depth. The reason is simple and highly visual. When sunlight strikes almost straight on from behind us, the bottoms and edges of craters are lit more evenly, weakening the cues our eyes rely on. Without strong side lighting, the surface looks smoother than it really is. It is a bit like looking at footprints at noon versus at dusk. The shapes are still there, but their depth is harder to judge. This makes the full moon a subtle trickster. It presents the most complete face, yet it may hide the violence that shaped it. Massive impact scars are still written on the surface, but the lighting softens their relief. A battered world suddenly looks more peaceful simply because the direction of light changed. Of course, not all details disappear. Some lunar rays are clearest at full moon and vanish at other times. Stretching across the moon are strange, bright streaks that look like frozen splashes from giant impacts, radiating out from certain craters for hundreds of miles. These are lunar rays, and they often become most conspicuous during the full moon phase. In other phases, they blend into the general brightness and shadow of the terrain, becoming hard to see. But when the light falls more directly and the contrast shifts, these rays stand out with startling clarity. They look almost painted onto the surface. What you are seeing is material blasted outward by an impact long ago. Some of these ray systems are so large they span multiple regions. They give the moon a look of violent, explosive history that the smooth disk does not directly suggest. On the right night, the full moon phase turns these ancient blast marks into some of the most spectacular patterns visible from Earth. The most famous of these are the bright rays of Tycho crater. The bright rays of Tycho crater become spectacularly prominent during the full moon. One of the moon's most famous landmarks is Tycho, a relatively young impact scar in the southern part of the lunar near side. From it, pale rays shoot out in all directions like little spokes or cracks in glass after a heavy blow. In many phases, these streaks are less obvious, but near the full moon, they burn with astonishing force. Suddenly, the moon looks less like a tranquil landscape and more like a record of catastrophe. Tycho itself is the product of a violent collision that scattered material across vast distances, and the bright rays preserve that event as a visible feature. Through binoculars or a small telescope, this may be one of the most exciting discoveries. The traces of a single collision are large enough to be seen from Earth with ordinary equipment. The full moon gives that ancient explosion its best stage lighting, and the result is unforgettable. Beyond Tycho, the full moon highlights other impact scars. The full moon accentuates certain impact wounds, letting them stretch across the lunar surface. Not every feature on the moon waits for the same lighting to be impressive. Some craters are most dramatic when the shadows are longest. Others assert themselves when the disk is full and bright ray systems begin to dominate the view. At those moments, the moon looks less like a landscape and more like an archive of impacts spanning deep time. Bright scars stand out against dark plains and ancient terrain, revealing where younger collisions have scattered fresh material. These traces can spread so far they seem too large to belong to a single event. But they do. A single strike can reshape a world's appearance. This is one reason the full moon phase matters to observers. It brings out the violence written in brightness rather than in shadow. You are not just admiring a glowing disk, you are watching some of the moon's wounds flare up in visibility, telling the story of its relentless bombardment. Faced with these scars, the human imagination takes flight. People once thought the dark patches on the full moon formed a human face. Once you notice the pattern, it is hard not to see it. Two darker areas suggest eyes, another patch becomes a nose or mouth. The contrast between light and dark tempts the brain to assemble features, and suddenly, the moon seems to be looking back at you. This is not ignorance, it is a deeply human habit. Our brains are wired to find faces even where none were intended. We do it in clouds, tree bark, toast, and in the arrangement of lunar planes. For many generations, that face on the moon became a familiar cultural image, repeated in stories, songs, illustrations, and nursery rhymes. It gave the moon personality and presence. A bright disk became a companion with an expression. This reaction is fascinating because it sits at the intersection of astronomy and psychology. The moon provides the pattern, the human brain provides the portrait. Together, they created one of the oldest imagined faces in the sky. That face is not the only answer. Other cultures saw a rabbit, a toad, or a tree in it. The dark patches on the moon were never limited to a single interpretation. Around the world, different cultures looked at the same bright disk and found completely different images. In parts of Asia and the Americas, the rabbit is one of the most enduring lunar images. Elsewhere, people saw a toad, a woman, or a tree. These were not random guesses. They were shaped by local stories, beliefs, animals, and symbols already important on Earth. The same moon became many things because the human imagination, like culture itself, was guided by vision. This is what makes these lunar images so captivating. They show that the sky is shared, but the people beneath it never saw it in exactly the same way. The moon became a mirror of the mind. It offered the same markings to every society, then let each culture draw meaning from them in its own language. One celestial face inspired many earthly tales. Long before science explained these scars, myth held sway. Long before telescopes explained its wounds, the full moon sparked stories about the sky. Long before anyone understood impact basins, lava plains, or orbital dynamics, the bright full moon was already one of humanity's great storytelling prompts. It was too conspicuous to ignore, too prominent to seem empty. People wondered what it was, who lived there, why it changed, and what it meant for life below. Thus, stories grew around it. Some explained the dark patches as figures placed in the heavens. Some viewed the moon as a god, a timekeeper, or a witness to human affairs. Others linked it to hunting, planting, fertility, or fate. These stories were not failures of intellect. They were early attempts to weave the sky into human meaning. The full moon, in particular, provoked this response because it was so visible, so memorable, and so easily passed down through generations. Even after science began explaining the moon in physical terms, the storytelling instinct never died. Knowledge changed the details, but the wonder kept speaking. This narrative is often tied tightly to the seasons. Many full moon names come from the seasonal rhythms of Earth. People name the bright moons not just for poetry. In many traditions, those names helped link the sky to recurring events on the ground. The full moon near harvest time mattered because the crops were ripening. The moon linked to deep winter, spawning fish, falling leaves, or blooming plants mattered because those changes shaped work, travel, food, and ritual. These names acted as memory hooks, tying the celestial cycle to the turning year. They also reveal an important truth about human attention. For most of history, people watched the sky and the land closely because survival depended on recognizing patterns. The moon became part of a larger system of seasonal awareness. A named full moon was not just a spectacle overhead, it was a signpost in the calendar of lived experience. Even now, These names persist because they connect the night to the world beneath our feet. The moon is still above us, but its meaning is often born in rivers, forests, fields, weather, and the labor of ordinary people. The most famous of these is the harvest moon. The harvest moon is the full moon closest to the autumnal equinox. The term sounds ancient because it is rooted in real seasonal need. As summer ends and autumn begins, the fields enter one of the busiest times of the year. Grain must be reaped, fruit gathered, and the weather may turn cold soon. The full moon closest to the equinox earned special attention because it appeared during that period of urgent labor. People noticed it not just because it was a lovely object in the sky, but because it was part of the rhythm of survival. It belonged to the harvest season. This connection gives it enough weight to endure into modern times. Even for those far removed from farming, the phrase still carries power. It links a bright moon to that special hinge moment of the year when days shorten and the landscape changes. The sky and the earth seem, for a brief time, to speak the same language, and the full moon becomes part of the story of autumn's turning. The harvest moon has a curious property. The harvest moon can rise with an unusually small delay over several consecutive nights. Most people learn that moonrise is later every night, which is true. However, around the harvest moon, something more subtle happens. Near that season, for many northern hemisphere observers, the angle at which the moon's path meets the horizon is shallower. Therefore, the usual delay between one moonrise and the next becomes smaller than expected. Instead of appearing much later each night, it might rise at nearly the same time for several nights in a row. This produces an extraordinary effect. The bright moon seems to keep close company with twilight, which is exactly when extra evening light is most needed. It is one of those astronomical details that feels almost tailor-made for human life, even though it is just geometry and timing. Still, the effect seems generous. The sky behaves slightly differently at exactly the right time of year. The harvest moon is named not just for the season, but for how its performance fits the name. This brief delay was once a lifesaver. This brief pattern once provided farmers with extra light during the harvest. Before electric lights blanketed the countryside, even small changes in evening light could matter. Fields did not harvest themselves, and autumn brought pressure. Crops had to be brought in before storms, rot, or early frost ruined months of work. Around the harvest moon, the reduced delay in moonrise meant bright nights followed one after another, extending working hours at a critical time. People could see well enough to continue cutting grain, stacking sheaves, loading carts, or crossing fields after sunset. It did not turn night into day, but it made a practical difference. This is part of why the harvest moon is more than just a pretty seasonal phrase. It was remembered because it helped. The full moon became a partner in labor, not just a spectator above. The idea is moving. An otherwise indifferent celestial cycle became intertwined with human effort, earning gratitude, attention, and a lasting place in tradition. Following close behind is the hunter's moon. The hunter's moon comes right after the harvest moon in ancient naming traditions. Once the harvest was largely done, another seasonal phase took focus. The fields were cleared, the leaves were thinning, and animals were sometimes easier to spot in more open ground. In many traditions, the full moon following the harvest moon was called the hunter's moon, linking it to a period when the focus shifted to gathering food stores for the harsher times ahead. Whether through hunting, preserving meat, or preparing for winter, people read the seasons in the sky and named them accordingly. What is fascinating is the practicality of these names. They were not random decorations attached to the moon. They reflected the shifting work, weather, and survival of the yearly cycle. The hunter's moon carries that sense of transition. Autumn is deepening. The abundance of harvest is giving way to preparation and pursuit. The bright disk overhead becomes a marker that the season has shifted and human attention must shift with it. Sometimes, the moon performs a little magic, appearing twice in one month. The blue moon is usually the second full moon in a single calendar month. This modern definition is famous because it is easy to remember and captures a real quirk of the calendar. The moon's cycle does not fit neatly into our months. So occasionally, a month manages to contain 2 full moons instead of 1. When this happens, the second is popularly called a blue moon. It does not actually look blue. The name is about timing, not color. Part of its charm is the surprise. The full moon feels regular and familiar, yet every so often the calendar slips a little, producing an extra full moon. This reminds us that our month names and page layouts are human systems placed over older celestial rhythms that do not obey them perfectly. This mismatch creates rarity. The blue moon is special not because the moon behaves strangely, but because our calendar briefly reveals it never had full control. The sky keeps its own schedule, and sometimes that shows. The definition of a blue moon has an older layer. Sometimes, blue moon refers to a rare seasonal full moon. Before the popular monthly definition spread widely, there was another meaning that remains significant. In that older usage, a blue moon referred to an extra full moon within a season that already contained the usual number of full moons, making it the 4th full moon in that seasonal span. This may sound slightly more complex, but it stems from a calendar that tracked the relationship between lunar phases and the turning year with great care. The phrase reminds us that names can carry layered stories. One expression, 2 legitimate traditions. This is interesting in itself because it shows that stargazing is not just about astronomy, but about culture, memory, and how people choose to organize recurring events. Blue moon is famous as a symbol of rarity, and both meanings support that feeling. In either case, the moon itself does not turn strange or change color. What changes is the framework we use to count it, and that framework occasionally produces a rare extra occurrence. There is also a moon called the supermoon. The supermoon is a full moon occurring near perigee. The moon does not orbit Earth in a perfect circle. Its orbit is slightly elongated, meaning it is sometimes closer to us and sometimes drifting farther away. The nearest point in its orbit is called perigee. When a full moon happens near that point, it is often called a supermoon. The term sounds dramatic, and in some ways it is deserved. The moon is indeed closer than usual, so it appears slightly larger and brighter than a full moon at a more distant point. This is fascinating because of the combination of familiarity and motion. The moon seems so constant that many people never suspect it is secretly creeping closer or drifting away. Yet it moves. A full moon near perigee makes this orbital change visible to the average observer. A world that already dominates the sky suddenly feels more present, more potent, and harder to ignore. Do not expect it to be as big as a wagon wheel, though. The supermoon looks larger, though the difference is more subtle than you might expect. Pictures and headlines might suggest the supermoon will take up half the sky. But the real difference is more modest. Compared to a full moon at a more distant point, the increase in apparent diameter is noticeable, especially to experienced observers or with careful side-by-side comparisons. However, to the casual eye, it is usually not overwhelming. This is important because the real charm lies in reality, not exaggeration. The moon does not need to be gigantic to be interesting. What matters is that its changing distance can be seen from Earth without any advanced equipment. That is remarkable. A subtle shift in orbit translates into a visible effect in the sky. So the supermoon is a lesson in tension. It rewards careful watching rather than just expecting spectacle. Many of the best wonders in the sky are like this. They are not loud or theatrical. They are subtle hints that the universe is moving with more delicate nuance than a first glance suggests. Opposite the supermoon is the micromoon. The micromoon is a full moon occurring near apogee. If the supermoon is the full moon at the moon's closest point, the micromoon is the opposite. It occurs when the full moon is at apogee, the farthest point in the moon's orbit from Earth. The result is a disk that looks slightly smaller and dimmer than usual. It still looks majestic, of course. The moon remains the dominant light source in the night sky. However, this more distant version reveals an elegance in celestial motion. The same familiar full moon phase returns, but under slightly different conditions dictated by an orbit that always carries the moon through changing relationships with Earth. The micromoon reminds us that not all full moons are equal in distance, even if they feel equal in significance. It adds depth to the concept of the lunar return. The cycle repeats, but it is never a perfect copy. Every return carries tiny variations, and sometimes those variations place the moon at the far end of its monthly wanderings. Even the distant full moon easily dominates the sky. This may be the most revealing fact about the power of the full moon. Even at apogee, looking slightly smaller than average, it still overwhelms the darkness. Stars dim, the landscape brightens, and people stop to look up. The moon does not need to be at its closest point to command attention. Its basic presence is already so vast in human experience. This fact helps put orbital changes in perspective. Yes, some full moons are closer, some are farther. Yes, size and brightness vary. But the deeper truth is that our nearest celestial neighbor remains dominant, visually and emotionally, across all those differences. The micromoon is not a lesser spectacle. It is proof of how powerful the moon's hold on us already is. Even at the far end of its orbit, a barren world of rock and dust can still occupy the sky and the imagination. Distance changes, but the spell remains. Now, let us talk about photographing the moon. The giant moon in photos is usually just clever lenses. When people see those famous pictures of a huge full moon looming behind a city skyline or balanced atop a distant tower, they often think the moon itself has swollen to an incredible size. Actually, what changes is photography. Telephoto lenses compress distance, making faraway objects appear stacked much closer together than the human eye sees them. The moon stays the same, the buildings stay the same. Yet the camera rearranges their apparent relationship, turning an ordinary moonrise into a dramatic, almost surreal scene. This is why those images feel so stunning. They reveal not a giant moon, but a massive gap between perception and technology. Photographers often scout locations with amazing care, waiting for the precise alignment of moon, landscape, and viewpoint. It can require planning, patience, and luck. So those breathtaking images are not fake in a simple sense. They are real scenes shaped by optics, geometry, and timing, which makes them a fascinating art form. Also, your eyes and your camera see the moon differently. Your camera and your eyes judge the moonlight differently. Human vision is incredibly adaptive. When you stand under a bright full moon, your eyes adjust to the dark and construct a richer experience from limited light. The landscape may feel luminous, spacious, and full of detail. The camera does not experience the scene that way. It records based on exposure settings, sensor limits, and the specific balance between bright and dark areas in the view. This is why moonlit scenes often disappoint beginners. The moon itself may become a white, featureless blob, while the foreground sinks into darkness. Or the land may be well exposed, but the moon becomes a blown-out, unnatural white. The camera is not wrong, and your eyes are not wrong. They are different systems for gathering light and interpreting contrast. This difference is part of what makes lunar photography so interesting. It forces you to realize that viewing is not a single process. The night sky changes depending on the instrument, and your own eyes are one of the most remarkable instruments you have. This also leads to shooting mistakes. Photographing the full moon requires exposures closer to daytime photography than people expect. Many beginners think that since the moon hangs in the dark sky, it must need a long nighttime exposure. That sounds logical at first, but it leads straight to disappointment. The moon itself is in direct sunlight, and that matters far more than the surrounding darkness. If you expose it as a dim nocturnal object, the bright lunar surface quickly becomes a washed-out patch with little visible detail. This surprise is instructive because it teaches an important rule about observation. The lighting on the subject matters more than the surrounding atmosphere. Although the full moon seems serene in the dark sky, the surface is illuminated more like a sunlit landscape than a typical night scene. This is why lunar photography feels counterintuitive. The emotional setting says night, but the exposure logic says something closer to day. Once people grasp this contrast, the moon becomes easier to photograph and even more fascinating to contemplate. The most common mistake is overexposure. The full moon is bright enough to often mislead beginners into overexposing. This is one of the classic errors in lunar photography. Someone raises a camera, sees darkness everywhere except that glowing disk, and thinks the moon needs help. So they lengthen the exposure or crank up the ISO. The result is often disheartening. Delicate tones vanish, crater details disappear, and the moon turns into a flat, white coin with no character. This failure is enlightening because it reveals how deceptive brightness can be in context. Against the dark sky, the moon feels like a soft lantern. But to the camera sensor, it can be a glaring, bright target. Learning to photograph it well requires learning not to trust first impressions, treating the moon as a brightly sunlit object rather than a nocturnal ornament. In this sense, the camera becomes a teacher. It shows that the full moon phase is not just pretty, it is optically demanding. The moon is bright enough to punish assumptions, making success feel especially rewarding. Of course, getting it right is worth it. Full moon photography often reveals details casual stargazers miss. A camera with steady support, careful exposure, and a decent lens can capture the moon in ways the naked eye usually cannot. Bright rays become more distinct. The boundaries between dark plains and bright highlands sharpen. Subtle tonal differences in the surface emerge, and the moon starts to look less like a simple glowing disk and more like a place with distinct regions and a history. This is one reason photographing the full moon is so rewarding. It transforms a familiar sight into an invitation for deeper study. You may have looked up at the moon countless times, but a photo shows you patterns you never noticed before. The image lingers, deepening attention beyond a passing glance. In this way, photography acts as a patient second pair of eyes. It does not replace wonder, it extends it. The more the moon is examined, the richer it becomes. A good image lets the eye keep exploring a world that might otherwise be dismissed as just a bright circle in the sky. Beyond photography, observing a lunar eclipse is a major joy. During a lunar eclipse, the full moon turns coppery or blood red. Few sights in the sky are more dramatic than watching a familiar bright moon lose its silver light and dim to red. This transformation can feel almost supernatural, helping explain why lunar eclipses have stirred fear, ritual, and awe throughout history. Yet, the cause is physically beautiful. When the moon moves into Earth's shadow, direct sunlight no longer reaches it. If the alignment is deep enough, the moon should vanish into darkness. Instead, some light bends through Earth's atmosphere and spills into the shadow. Along the way, the bluer tones are scattered out, and the red tones survive more effectively. That filtered light then reaches the moon, painting it copper, rust, or deep blood red. So the eclipse does not extinguish the moon entirely. It changes the kind of light that finds it. A bright companion becomes a dim ember in the sky, and for an hour or two, the moon looks like a completely different world. Imagine that the red eclipsed full moon is illuminated by all the sunrises on Earth. This may be the most staggering way to think about a lunar eclipse. When the moon is deep in Earth's shadow, it is not shining with direct sunlight. Instead, the light reaching it has skimmed through Earth's atmosphere. From the moon's perspective, all the sunrises and sunsets on Earth are happening simultaneously along the planet's edge. That red light is collected, filtered, and redirected into the shadow, gently illuminating the lunar surface. In a sense, the eclipsed moon glows with the combined color of Earth's atmosphere. The idea gives the event extraordinary depth. You are not just watching the moon darken, you are seeing our planet participate in the picture. Earth is no longer just the ground beneath your feet. It becomes an optical actor in space, casting a shadow and coloring the light within it. The lunar eclipse becomes a portrait of the Earth-Moon system working together. Of course, a lunar eclipse only happens during a full moon. This rule is pure geometry. For Earth to cast a shadow on the moon must be on the far side of Earth from the sun. That is the alignment of the full moon phase. A crescent or half moon is simply not in the right position for such an event. This is why lunar eclipses feel so satisfying intellectually. The spectacular red moon is not random, it is the natural result of celestial alignment. The sun, Earth, and moon must line up almost perfectly, with Earth in the middle. When they do, the familiar disk enters the shadow, and the show begins. This connection makes the lunar eclipse a perfect example of how astronomy can turn drama into clarity without reducing the wonder. The explanation does not flatten the event, it deepens it. The next time a full moon rises, you can know that every eclipse begins with something that seems ordinary. The extraordinary happens when the alignment becomes precise and Earth's shadow finds its mark. Most of the time, the moon is uneventful. The full moon is bright enough to cast sharp shadows on the ground. This fact shocks those who have mostly seen it under city streetlights. Step into the dark countryside at the right time, and the change feels almost magical. Fences draw lines on the ground, branches trace patterns, and your own shadow can follow you, pale and strangely soft. This is no trick of the imagination. The light is genuinely strong enough to shape the contrast of the landscape. Explorers, farmers, sailors, and night travelers once relied on this difference. A bright moonlit night was not just beautiful, it was useful. It changed the hours when people could move, work, and navigate. Moonlight shadows also have something deeply unsettling and fascinating about them. They resemble daytime shadows, but the world is still soaked in the silence and blue tones of night. Familiar places seem both known and altered. This strange mix is part of the full moon's power. It preserves the mystery of darkness while borrowing enough light to redraw the world. Most full moons miss Earth's shadow, shining untouched. If the full moon and lunar eclipses are so closely linked, why isn't there an eclipse every month? The answer lies in the tilt of the moon's orbit relative to Earth's path around the sun. Most months, the full moon is just slightly above or below the line of perfect alignment, so it does not enter the shadow. The result is an ordinary bright full moon, not an eclipse. This is a brilliant reminder that celestial events depend on precision. Rough alignment is not enough. The geometry must be exactly right for the shadow to hit the target. Because it usually is not, most full moons remain clear, unaffected by Earth's darkness, continuing to shine relentlessly. This ordinary outcome is easily overlooked because eclipses are so memorable. Yet, it is the missed shadows that make eclipses special. Rare drama depends on many quiet months where the moon glides past unscathed, bright and whole. Sometimes, the moon grazes the edge. Some full moons drift gently through the penumbra, so gently that few people notice. Not every eclipse announces itself with a red moon or a chunk bitten out of the disk. Sometimes, the moon only passes through Earth's penumbra, the outer, softer part of the shadow. In this case, the change can be subtle enough that a casual observer sees nothing at all. The moon may just dim slightly on one side, as if veiled by a thin gauze. This restraint is fascinating. We often imagine celestial events as obvious spectacles, but the sky also offers refined performances that reward close attention. The penumbral eclipse is one of these. It asks the observer to notice nuance rather than transformation. The familiar full moon remains almost itself, but not quite. Once you know what you are looking at, that slight difference becomes strangely compelling. It reminds us that shadows in space have layers, and even an event most people never register is still the result of one world drifting along the dark edge of another. This orbital tilt is a testament to the universe's precise calculations. The full moon reveals the inclination of the moon's orbit. At first glance, it seems the moon travels a simple path around Earth, like drawing a circle with a compass. In reality, the orbit is slightly elliptical and tilted relative to Earth's path around the Sun. This tiny tilt is easily missed until you think about eclipses. The full moon means the moon is on the far side of Earth from the Sun, which sounds like prime shadow territory. Yet most months, nothing dramatic happens. The bright disk sails by, completely missing the shadow. This quiet miss is the clue. It tells us the moon usually runs just above or below the line needed for an eclipse. In other words, the ordinary full moon is evidence of orbital tilt. You can almost read the angle of inclination from the absence of spectacle. This is one of the loveliest things about astronomy. Sometimes the sky reveals its structure not through rare fireworks, but through the calm repetition of things that do not happen. If there were no tilt, every full moon would bring an eclipse. Imagine if every full moon darkened and turned red, that would be the norm. If the moon traveled in the exact same plane as Earth's journey around the Sun, this perfect alignment would occur. In that perfect alignment, Earth would stand directly between the Sun and Moon every time, and its shadow would sweep across the lunar surface without exception. That is not what happens. And that is one of the most important clues about how the system is arranged. A tiny tilt is enough to spare most full moons from eclipse. That tiny angle changes everything. It turns monthly certainty into occasional events, and rarity gives eclipses much of their power. They are special moments when the moving parts align tightly enough for the shadow to hit the target. So, the next ordinary full moon carries an invisible lesson. It is bright because the geometry is slightly off, and that slight offset is enough to preserve the familiar light of night. The moon's orbit itself is not a perfect circle. The moon's orbit is not a perfect circle, so every full moon is different. It is easy to imagine the moon traveling in a uniform orbit around Earth, drawn with a compass. Actually, the orbit is slightly elliptical. This means the moon is sometimes closer to Earth and sometimes farther away during its monthly journey. The full moon phase can occur at any point along this varying path, giving one full moon a different apparent diameter, size, and brightness than another. These changes are not usually dramatic enough to shout for attention, but they are real, measurable, and surprisingly meaningful. They remind us that repetition in the sky is rarely exact replication. The moon returns in phase, but not as a perfect duplicate of itself. Variations are folded into the cycle, making the full moon more interesting than a simple clock hand. It is a recurring event carried by a path with subtle stretches and asymmetries. The sky repeats its patterns, but not by printing them from a single, unchanging mold. This variation in distance is also random. The full moon might happen within hours of perigee, or it might be far from it. Perigee is the point where the moon is closest to Earth in its orbit, and the full moon phase is a separate point in time, set by the moon's position relative to the Sun. Sometimes these two rhythms coincide perfectly, sometimes they are far apart. This means one full moon might occur when the moon is near its closest point, while another might happen when it is nowhere near that part of the orbit. This ever-changing relationship is a beautiful example of how different celestial cycles overlap. The moon does not follow a single timetable. It follows several timetables at once, and their combination constantly produces new variations. This is why some full moons get extra attention while others pass more quietly. Even though the phase itself is the same, the timing underneath has changed. The bright disk becomes a moving intersection of orbital patterns, and its character depends on how those patterns align in that particular month. More interestingly, Earth is not a stationary center either. Earth and the Moon both orbit a shared balance point in space. Many imagine the Moon spinning around a perfectly still Earth, but that is not entirely correct. Earth and the Moon both orbit around a common center of mass, a balance point created by their mutual gravity. Because Earth is so much more massive, that point lies inside our planet, though not at the exact center. Even so, the important truth remains. The Moon is not just dancing around a pillar like Earth. Both worlds are in shared motion. This gives the Earth-Moon system a more subtle elegance. The larger world still yields slightly to the smaller one. This shared motion is not something you see when you look up at the full moon. Yet it is part of the reality behind every moonrise and moonset. The Moon is not just our captured companion. It is a partner in a gravitational relationship, and even our planet must alter its posture in response to that partnership. Gravity is mutual. Even at full moon, Earth's pole and the Moon's pole are mutually shaping each other. The bright round face in the sky may look calm and detached, but gravity is binding Earth and the Moon in a continuous physical dialogue. Earth's gravity holds the Moon in orbit, and the Moon's gravity, in turn, acts on Earth, pulling the oceans and even slightly affecting Earth's solid body. The Moon is not powerful enough to dominate Earth, but it is strong enough to have profound effects. This relationship is two-way. Earth helps lock the Moon into showing us only one face, and the Moon, in return, lifts the tides and causes the slow, long-term slowing of Earth's rotation. This means the full moon phase is not just an image. It is a moment in an ongoing exchange of forces. The beauty overhead is supported by invisible tension between two worlds that have been shaping each other for vast ages. When you look at the full moon, you are not seeing an isolated object. You are seeing half of a gravitational partnership. This pull even breaks the Earth. The full moon helps slow Earth's rotation by lifting tidal bulges. The Moon's gravity pulls unevenly on Earth because the side facing the Moon feels a slightly stronger pull than the far side. This difference helps create tidal bulges in Earth's oceans. As Earth rotates, the situation is complicated by friction and motion, and these bulges do not stay perfectly aligned with the Moon. Instead, they get dragged forward slightly. This offset matters. The bulge pulls back on the Moon pulls on the bulge, creating a transfer of energy and angular momentum that gradually slows Earth's spin. This change is tiny over a human lifetime. However, over vast spans of time, it accumulates. Days were shorter in the ancient past. This is staggering because it means the full moon is linked, in a slow, long-term way, to the very length of a day. A bright disk rising over the horizon is part of a process that has been gently breaking our spinning planet. The same tidal dance is also slowly pushing the Moon farther away. This is the action of tidal forces. The slowing of Earth's rotation is only half the story. As tidal forces siphon off a tiny bit of rotational energy from Earth, some of that energy is transferred to the Moon's orbit. The result is that the Moon is gradually moving outward, drifting farther away over time. This is not guesswork. Scientists can measure this recession with stunning accuracy using reflectors left on the Moon by astronauts. Laser pulses are fired from Earth and bounce back, allowing the distance to be tracked with extreme precision. This means the full moon we see tonight was not in this position in the ancient past. The change year over year is minuscule, but over millions of years, it is relentless. Our nearest celestial companion is slowly drifting away. The idea is somewhat poignant. The moon that shapes our tides, our stories, and our nights is not fixed forever in that spot. It is part of an evolving system, and the distance between our two worlds is still being rewritten. Looking back into the past, we would find the ancient full moon was larger. The ancient full moon was larger because the moon orbited much closer to Earth then. Going back far enough in time, the moon would have looked more imposing in the sky. because tidal interactions have been pushing it outward for eons. The earlier moon ran its orbit at a smaller distance. A closer moon would have appeared larger, brighter, and its gravitational effects on Earth would have been stronger. Imagine ancient coastlines under a larger, brighter full moon and more powerful tides. This is not fantasy. It is the natural result of an evolving orbit. The moon we know now is just the latest version of this long-term relationship. This fact adds an exciting dimension to deep time. Even in what seems constant, the night sky itself looked different in Earth's early eras. When we picture the distant past, we think of different continents, climates, or creatures. We rarely remember that the moon above was different too. Dinosaurs basked in moonlight. They watched the same phases, the same bright circle rising over ancient horizons. Yet the moon above their world was slightly closer than the one we see today, meaning it would have appeared slightly larger in the sky. The difference was not huge from one generation to the next, but over tens of millions of years, it was real. It is a fact that connects ordinary experience with prehistoric scale in a single image. A dinosaur standing beside a fern forest looked up at the full moon, sharing something with us, yet not exactly the same. The sky has changed. The idea is powerful because it makes the moon part of Earth's life story. It witnessed worlds long gone. Even in its apparent constancy, it is slowly changing, enough to escape notice, yet certainly changing. The influence of the full moon on biology is everywhere. The full moon can disrupt the darkness by changing brightness, altering animal behavior. In nature, the night is not a single thing. It can be pitch black and hiding, or bright enough to reshape the choices animals make. When the moon becomes full, the change in brightness spreads across forests, coastlines, grasslands, and open waters. Creatures relying on darkness as cover may move less, feed differently, or hide longer. Others may use the extra light to travel farther, spot rivals, or locate mates. In this sense, the full moon does not just illuminate the landscape. It temporarily rewrites the rules of the night. Biologists sometimes call this the landscape of fear or the landscape of opportunity under the moon, depending on the animal. The important thing is that moonlight becomes an ecological force. A bright sky can change risk, timing, and behavior without making a sound. So the full moon is not just a human spectacle. It is part of the environment that silently alters what is possible in the dark for countless species. Coral is one example. Some coral species time their mass spawning around the full moon. On certain nights in warm ocean waters, one of the most extraordinary coordinated events on Earth can unfold. Corals, which grow silently all year, release eggs and sperm into the water almost simultaneously, turning the sea into a drifting cloud of future life. In some species, this timing is linked to the lunar cycle. The full moon helps provide a reliable cue, combined with season, temperature, and day length. The precision is astounding because corals do not have brains in the usual sense, nor eyes to see the sky, yet entire reefs react with breathtaking coordination to celestial timing. This matters because successful reproduction depends on many individuals releasing gametes at the same time. The moon becomes part of the reef's choreography. What looks like a quiet underwater city is actually syncing with the sky. The bright phase overhead helps trigger one of the most important and beautiful reproductive events in the ocean. Fish do it too. Grunion run ashore to spawn during the high tides of the full and new moons. Along parts of the Pacific coast, a silvery little fish performs a ritual so strange it almost sounds invented. On a few nights around the highest tides of the full and new moon phases, grunion ride the waves up onto the beach. Females twist their rear halves into the wet sand, laying eggs beyond the usual reach of the waves, while males curl around them to release sperm. Then the adults return to the sea, leaving the buried eggs behind. Days later, when an exceptionally high tide returns, the waves free the hatchlings and carry them out to sea. This is lunar timing made visible in the most dramatic way. The moon is not just bright in the sky. Through tides, it helps set the schedule for a fish to leave the water and reproduce on the land's edge. This is the kind of full moon story that overturns expectations. A celestial cycle becomes a coastal survival strategy, written into motion. Predators also watch the moon. Predators often hunt differently when the full moon brightens the landscape. A brighter night changes the balance between hunter and hunted. For some predators, more light can be useful. Owls may spot movement more easily in open areas. Mammals that hunt by sight may patrol territories with more confidence. Shorebirds, foxes, coral reef hunters, and many others may experience the night differently when the landscape is not wrapped in deep darkness. However, the advantage is not always straightforward. A bright sky can also expose the predator itself, making stealth harder and reducing the element of surprise. This is why scientists often find no universal rule, but rather patterns shaped by habitat, species, and hunting style. The most fascinating part is that the full moon becomes a variable in survival strategy. A predator does not enter the same night every time. It enters a version of the world where visibility has changed. Increased light can ripple through the ecosystem, altering motion, timing, risk, and success. Prey are more cautious. Some prey animals become more cautious on bright full moon nights. For animals relying on darkness as a shield, moonlight can feel dangerous. A rodent crossing open ground may pause longer, stick closer to cover, or simply stop foraging. Small mammals, birds, reptiles, and even some marine creatures may reduce activity when they are easier to spot. This effect is not simple fear in the human sense. It is a pattern shaped by natural selection, where individuals behaving more cautiously under bright conditions were more likely to survive. This means the full moon influences not just predator behavior, but also what prey decide not to do. Food may go uneaten, journeys may be postponed, mating calls may decrease. The brightness of the night alters the cost of exposure. What makes this so intriguing is the silence of the mechanism. The moon does not command these animals. It changes the visibility, and visibility changes behavior. The bright disk overhead becomes part of the mathematics of survival in the dark. Insects get disoriented too. Nocturnal insects can become confused by strong moonlight and artificial light. Many night-flying insects navigate using light cues in the sky. And that system evolved in a world where natural light sources were distant and predictable. The moon, though bright, stays relatively stationary in the short term of a flying insect, helping with orientation. Modern artificial light creates a different problem. It is nearby, overwhelming, and confusing. Insects trying to use it as a reference may circle, spiral, or become trapped in futile flights. On bright moonlit nights, the situation can become more complex as natural and artificial cues compete or clash in a changed sky. Some insects may reduce activity under brighter conditions, while others fall into visual chaos, wasting energy and increasing danger. This is one of the more poignant consequences of electric lighting. We do not just illuminate the night for ourselves. We alter the navigation environment for creatures evolved under the patterns of the moon and stars. The full moon belongs to an ancient system. The street lamp does not. The fate of sea turtles is also linked to moonlight. Sea turtles use natural light cues that can become complicated on bright full moon nights. When sea turtles emerge from their nests, newly hatched turtles face one of nature's most urgent journeys. They must find the ocean quickly. On natural beaches, the brighter open horizon above the water helps guide them, contrasting with the darker landward side. Moonlight can be part of this visual world, reflecting off the water's surface and altering the brightness patterns they react to. Under natural conditions, this usually still guides them in the right direction. But where coastal lighting intrudes, the situation becomes difficult. Bright artificial lights from hotels, roads, or houses can compete with or overwhelm the cues sea turtles evolved to use. The result can be tragic disorientation, with hatchlings crawling inland instead of toward the waves. Here, the full moon stands at a crucial crossroads. It is part of the natural nocturnal system that shapes sea turtle behavior. Yet human lighting can disrupt that ancient guidance. A delicate journey of life and death stumbles at the very first step. Desert dwellers understand this too. Some desert creatures wait for darker nights rather than the brightness of the full moon. Deserts may seem empty during the day, but many of their inhabitants come alive after sunset. For these animals, darkness is a refuge from heat and sharp-eyed predators. When the full moon illuminates open sand and sparse ground cover, that refuge thins. Some rodents reduce activity. Certain insects hide longer. Small creatures that would normally cross open ground may postpone their trips until the sky is darker. In habitats with little cover, moonlight can make every shadow matter. This is one reason the lunar cycle affects activity so strongly in deserts. A bright night is not just a visual change, it can alter feeding schedules, mating opportunities, and the routes animals are willing to risk. The desert illustrates this especially clearly because the landscape offers almost no hiding place. The full moon turns open ground into a lit stage, and not every creature wants to perform under that light. Even human sleep is affected by it. In some studies, human sleep shows subtle changes around the full moon. The idea that the moon affects human sleep has long fascinated people, and modern research has produced some interesting but inconsistent hints. In some studies, participants took slightly longer to fall asleep, slept slightly less, or showed minor shifts in sleep patterns during the full moon phase. These effects are generally mild, not dramatic, and they do not appear with the same strength in every study or every person. This uncertainty is part of what makes the question interesting. Human sleep is influenced by many factors: light exposure, daily stress, pressure, and expectation. The moon may be one subtle factor among many, or its apparent influence may vary with the environment. Regardless, the question remains compelling because it touches something ancient. For most of human history, nights were darker and more directly shaped by moonlight. Our sleep may still carry a faint echo of that world, and the possibility is hard to dismiss entirely. The most exaggerated claims about lunacy remain scientifically unproven. Stories about strange behavior, crazy crowds, chaotic emergency rooms, and sudden human irrationality under the full moon are deeply rooted in culture. The moon has long been seen as a trigger for turmoil, which is why words like lunacy carry an echo of the moon. However, when scientists carefully search for consistent evidence linking the full moon phase to crime, illness, accidents, or mental disturbance, the wildest claims generally fail to hold up. This does not make the myths stupid, it makes them revealing. The full moon is bright, memorable, and emotional, so unusual events happening under it are easier to notice and remember. Quiet, ordinary nights are forgotten. A bizarre story paired with bright moonlight sticks in the mind. This is the classic recipe for belief. The lesson is not that the moon is boring, quite the opposite. It is so powerful that people often grant it more control over human behavior than the evidence can support. Hospitals do not reliably become more chaotic because of the full moon. The aura is overflowing during the full moon is a stubborn modern legend. Nurses have heard it, doctors joke about it, and patients repeat it. The story persists because it sounds plausible. The bright full moon carries centuries of folklore, and hospitals are places where people remember unusual nights intensely. However, when researchers examine records and look for consistently higher admission rates, injury rates, birth rates, psychiatric crises, or other hospital activity tied specifically to the full moon phase, the evidence generally fails to show a reliable pattern. This does not mean busy nights never happen during a full moon. Of course they do. The key is that they happen just as often under any other kind of moon. What makes the legend powerful is memory. A busy shift under bright moonlight feels significant and is easy to remember. An equally busy shift on a cloudy or dark night leaves less of an imprint. The moon becomes the story because the story is just too easy to love. Beyond influencing physiology, the full moon profoundly affects our psychology and culture. The full moon makes dark countryside look both familiar and alien at night. Places that vanish into mystery on moonless nights can suddenly reappear with enough detail to seem almost known. Lanes through fields, hedgerows, barn roofs, distant tree lines, all may re-emerge in pale outline. Yet this recognition is never complete. This is exactly why the experience feels so eerie. The world seems restored, but not quite. Shapes are clear, but color is almost gone. Distances may feel deceptive. Open ground may look flatter than it is. Water may glitter where there is only frost. Under bright moonlight, the countryside becomes a version of itself, translated into silver, charcoal, and soft contrast. For people before the grid, that version of the landscape must have been deeply familiar. It extended the useful hours of the night and changed the meaning of darkness. Even now, stepping into such a landscape can feel like entering an older world. The road is still ours, but the light belongs to an earlier era. This emotion gave birth to myths. Many lunar myths survived because bright nights feel different emotionally. A bright full moon does not just light the ground, it changes the mood. Familiar places look altered, yet recognizable. Distances feel uncertain. Shadows remain, but they are incomplete. The night seems simultaneously safer and stranger. This emotional shift matters because humans always create meaning from atmosphere as well as facts. A moonlit night can feel charged with emotion before anything unusual even happens. Once that feeling exists, stories naturally gather around it. The moon becomes a stage for omens, transformations, secret journeys, and restless thoughts. Myths endure not because the stories are scientifically true, but because they attach to a real experience. The experience is that the world feels different under bright moonlight. Even now, surrounded by streetlights and screens, a clear full moon can still stop people in their tracks, making the night feel like something special. Myths survive wherever emotion finds a place to settle. This inspiration crosses professions. The full moon inspired poets, priests, sailors, and scientists. Few objects in the sky speak to so many kinds of minds. Poets found rhythm, loneliness, romance, and memory in its light. Priests and ritual leaders linked it to sacred calendars, ceremonies, and signs of cosmic order. Sailors regarded it with practical reverence, as moonlight changed the ocean and night work. Scientists turned telescopes toward it and discovered a world of basins, mountains, lava plains, and impact scars. Remarkably, none of these responses cancels out the others. The same moon can be beautiful, useful, sacred, and measurable all at once. This is part of its lasting power. It refuses to be reduced to a single category of human thought. You can calculate its orbit while still feeling awe. You can understand its geology while still writing a song about it. For centuries, the full moon has been one of the few things that allowed emotion, observation, and reverence to stand side by side under the same sky. This all is even carved in stone. Ancient temples and monuments may have tracked the extreme positions of the full moon. Some ancient structures seem placed or aligned with incredible care. In many cases, researchers suspect certain sites were designed to mark not just the movements of the sun, but also the rare positions of the moon. The moon does not always rise and set at the same points on the horizon. Over a long cycle, those extreme positions shift, reaching particularly far points that are amazing to track. Certain monuments and stone alignments may have been designed to account for those northernmost or southernmost moonrises and moonsets. Evidence is stronger for some sites than others, and interpretation requires caution. Still, the possibility is exciting. It suggests that ancient observers were patient enough to track a pattern unfolding over years, not just a month or a season. If true, those places were not just built under the sky, they were built in conversation with it. Stone, memory, and moonlight may have been part of the same long act of attention. In terms of brightness contrast, moonlight is vastly dimmer than sunlight, yet far brighter than starlight. It occupies a strange middle ground, changing the night without truly erasing it. Under the sun, colors burst forth and details leap out. Under starlight alone, the land may dissolve into suggestions and outlines. Under bright moonlight, the world becomes readable again, albeit in quieter tones. You can follow a path, recognize distant hills, and see water gleam like metal. Yet much remains softened, drained of color, wrapped in shadow. This in-between quality may be part of what makes moonlit nights so memorable. They are not ordinary darkness, nor are they daytime. They create a third state, one our ancestors knew deeply. Painters, writers, and composers have long been drawn to this threshold where things are visible yet transformed. Science can describe the difference in brightness, but the experience is what lingers. The moon does not overwhelm the night. It negotiates with it, and the result feels almost transcendent. As the ruler of the night sky, the full moon can wash out the faint stars of the entire sky. On bright nights, the sky loses some of its depth. The stronger moonlight illuminates the background of the night, and stars that could pierce the darkness fade away. Constellations may become harder to trace. The faint glow of the Milky Way may vanish completely. To those new to stargazing, this is surprising. The moon does not block the stars. It simply fills the night with enough scattered light to drown out the dimmer ones. It is like trying to spot fireflies beside a floodlit field. They are still there, but the contrast is gone. This means the full moon phase changes the character of the entire sky, not just the appearance of the moon itself. A moonlit night draws attention back to our nearest celestial neighbor. A moonless night invites you outward toward countless distant suns. In ancient times, this brightness was a lifeline. Before electric lights, the full moon helped travelers cross land. Before streetlights, headlights, and illuminated roads, darkness severely limited movement. A bright full moon changed that. Trails that vanished on moonless nights could be followed again. Rivers, gates, fences, and landmarks became clear enough for navigation. People walking, riding horses, or driving carts could extend journeys that might otherwise have ended at sunset. This was especially valuable in open country, where moonlight could spread clearly over fields and roads. The moon did not eliminate danger, but it reduced some uncertainty. This practicality gave moonlit travel a place in memory and tradition. Night journeys by moonlight became part of ordinary people's lives, not just romance or folklore. It is easy to forget how important the sky once was for movement on Earth. The full moon was not just something to admire from a doorway, it was working light for real people on real roads, helping them travel farther through the dark. This importance is also embedded in ritual. Moonlit nights left their mark on festivals, rituals, and timekeeping around the world. Wherever people watched the sky closely, that recurring bright phase offered more than beauty. It provided a reliable public marker. The full moon was hard to miss, easy to remember, and visible to many people at once. This made it ideal for gatherings, rituals, offerings, storytelling, and marking shared time. Communities could tie important events to a visible signal rather than private records or abstract calculations. The result was a deep connection between lunar time and human culture. Dances, vigils, religious rites, and seasonal celebrations often found their place in that cycle. The moon helped tell people when to gather. This is why lunar traditions appear in so many places around the world. Even if the details differ greatly, a public time marked by a bright full moon is written across the sky, and that is common ground. It could summon a village, guide a ritual calendar, or anchor the memory of generations. The night itself became a meeting place. In religious calendars, the full moon is especially important. In some calendars, sacred days begin or end with the full moon. Not all calendars are structured the same way. Some rely primarily on the sun, some on the moon, and some combine both in complex systems. In lunar or lunisolar traditions, the full moon can serve as a natural anchor for sacred time because it is visually undeniable and rhythmically reliable. A sacred day might be set to begin, culminate, or end under that bright celestial signal. This gave sacred time a visible texture. The sky itself confirmed the arrival of a sacred period. This is a very different experience from glancing at a printed date. It means astronomy entered directly into devotion. Believers did not just memorize a calendar, they could look up and see it. Thus, the full moon became part of traditional emotional and ritual life, marking fasts, feasts, prayers, reflection, or pilgrimage. Sacred time was not hidden in paperwork. It was illuminated in the sky, shared by everyone standing under the same bright night. The most classic example is Easter. The date of Easter is tied to the full moon after the spring equinox. The most widely observed date in the Christian calendar does not fall on a fixed number each year because its timing depends on the relationship between the seasons and the moon. According to traditional rules, Easter is set for the Sunday following the Paschal full moon, the ecclesiastical full moon that falls on or after the March equinox. This means the celebration is linked to both the sun and the moon. Spring must arrive first, and then the lunar cycle helps determine the date. This is a beautiful example of how ancient religious calendars often retain traces of skywatching, even as daily life moved away from direct observation. A major festival still carries the structure of celestial timing. The moon is not just decorative in the symbolism of spring's renewal, it is built into the rule itself. The result is that Easter moves through the calendar, following a rule that combines sunlight, seasons, and moonlight in a single tradition. Buddhism follows this pattern too. Vesak, the Buddhist holiday, is linked to the full moon. In much of the Buddhist world, Vesak is one of the most sacred observances of the year, and its timing is tied to the full moon of a specific lunar month. Traditions vary by country and calendar, but the full moon remains central to the occasion. This connection gives the festival a special atmosphere. The night sky itself becomes part of memory and devotion. In many traditions, Vesak is associated with the birth, enlightenment, and death of the Buddha, making the full moon important not just for timing, but for framing one of the most profound spiritual observations. In the Buddhist calendar, temples may be illuminated, prayers may last late into the night, and the bright moon overhead may feel like part of the ritual rather than a separate backdrop. Here, the lunar cycle is not just a relic of history. It remains vibrantly alive in practice. Sacred memory and celestial rhythm continue to meet under the same luminous sky. The Mid-Autumn Festival in East Asian cultures takes this even further. The Mid-Autumn Festival celebrates the full moon in several Asian traditions. In many parts of Asia, the autumn full moon is not just observed, it is welcomed with celebration. Families reunite, share special foods, lanterns glow, and the moon itself becomes the focus of gratitude, appreciation, and togetherness. Details vary by region and tradition, but a common feeling often runs through it. The bright autumn moon is linked to harvest, abundance, family, and the turning point of the season. What makes these festivals especially moving is that they combine skywatching with human intimacy. The moon is not appreciated in isolation, it is appreciated in company. Children and parents look up together. Communities gather outdoors. Poetry, songs, and stories may accompany the viewing. A celestial event becomes a social and emotional event. This shows the most generous side of the full moon. It is not just an object of study or a spectacle. It is a reason to gather, a reason to remember the seasonal shift, a reason to make the shared sky part of shared life. Beyond festivals, the full moon also guided farming. The full moon once guided planting lore, although the evidence is mixed. For centuries, people looked to the moon not just for light and time, but for advice about the land itself. In many agricultural traditions, certain phases were considered favorable for planting, pruning, grafting, or harvesting. The full moon often held a special place in this lore because it was easy to identify and link to visible changes in the night. Some growers believed crops eaten for their tops benefited from one part of the lunar cycle, while root crops preferred another. These ideas still appeal to many because they connect farming to the broader rhythms of nature. However, when scientists test these claims carefully, the results are often mixed, inconsistent, or difficult to separate from weather, soil, season, and local practice. This tension is fascinating. The moon is clearly important in many natural systems, but not every ancient belief proves equally strong under experimentation. Even so, the lore persists because it gives agriculture a dimension of looking up at the sky. This gaze at the sky reveals the moon's brutal truth. Telescopes show that the beauty of the full moon comes from violence frozen in stone. To the naked eye, the full moon may look smooth, serene, almost peaceful. Put it under a telescope, and a crueler truth emerges. That bright face is a battered world. Its plains were shaped by massive impacts and ancient eruptions. Its craters were blasted open by collisions powerful enough to scatter rock across vast distances. Its surface dust was created by repeated destruction over unimaginable eons. The miracle is that such violence produced something so beautiful from Earth. The moon is beloved not because it escaped disaster, but because disaster wrote its history into every visible feature. The telescope turns that idea from poetry into evidence. What looks peaceful is scarred. What looks simple is layered with events of collision, melting, pulverization, and cooling. The full moon phase gathers all this history into one bright disk. What we see is not a preserved masterpiece. We see damage preserved so well it became beautiful. Every scar is a time capsule. Every full moon lets us see a history of impacts spanning billions of years. There is no rain on the moon to wash its surface clean, no rivers to reshape it, no forests to hide old wounds, and almost no active geology to erase the oldest records. This makes it one of the greatest memory banks in the solar system. Every full moon displays this archive. Craters large and small overlap on the visible surface, recording impacts from different eras of lunar history. Some belong to relatively recent geological events. Others date back to the earliest epochs of heavy bombardment that shaped many worlds. On Earth, most of this ancient evidence has been erased by plate tectonics, erosion, and oceans. On the moon, much more is preserved. This is one reason the full moon phase is so thrilling scientifically. It allows ordinary observers to stare directly at a record of cosmic impacts spanning billions of years. The bright disk in the sky is also a chapter of the earliest history of our neighboring planetary region, preserved for us to see. This clarity exists because there is no atmospheric interference. The full moon is bright because the moon has no air to soften the light. On Earth, everything is altered by air. Sunlight is scattered, filtered, reddened at low angles, diffused by clouds, dust, and moisture. The moon has no such blanket. Its surface is exposed to vacuum. Sunlight hits it without weather, haze, or atmosphere to soften the contrast. When that light reflects back to us during the full moon phase, it looks sharp and clean, feeling different from most earthly brightness. There is no lunar sky glowing around it, no blue firmament, no drifting clouds. Just hard sunlight hitting bare ground and traveling back across space. This is part of why the full moon can feel so crisp and absolute in a clear night sky. Its light is not just about reflection. It is about nothing being there to blur, scatter, or buffer the light before it begins its journey to Earth. When we look at the moon, we see it as it was just over a second ago. Moonlight takes just over a second to travel from the moon to Earth. This fact compresses a vast distance into a surprisingly short travel time. The moon is far enough to feel distant. Yet light moves so fast that the journey from the lunar surface to your eyes takes only slightly more than a second. In practice, this means when you look at the full moon, you are seeing it as it is now, at least by cosmic standards. Not instantly, but very nearly so. This makes moonlight feel strangely intimate. It crosses space, reflects off one world, and arrives with a delay barely perceptible to humans. Compare this to starlight. Some stars whose light we see tonight began their journey years ago. Some galaxies sent their light so long ago it predates human existence. In contrast, the moon is our nearby companion. Its light is fast enough to feel immediate, yet distant enough to remind us that even the nearest world in space is separated by staggering emptiness. This delay, though tiny, still exists. The full moon we see is already slightly old. Nothing in the sky is seen in the complete present because light always takes time to travel. For the moon, the delay is just over a second, small in daily life, but real nonetheless. So, every bright full moon is historical by the time it reaches your eyes. You are seeing it as it was a moment ago. This sounds trivial, but it carries a profound lesson. Even our nearest neighbor belongs to the past the moment it becomes visible. Astronomy is always an act of delayed viewing. For the moon, the delay is small enough to ignore. For stars and galaxies, it becomes enormous, spanning years, centuries, or millennia. So the full moon is a gentle introduction to one of the deepest truths in space science. Looking outward also means looking backward. Here, the difference is small, but it is serious enough to remind us that light always carries time. This play of light and shadow is one way during the full moon. Earthshine disappears during the full moon because the moon is already strongly lit by the sun. During the crescent phase, careful observers can sometimes see the dark portion of the moon glowing with a faint, ghostly light. That soft, spectral illumination is Earthshine, sunlight reflected off Earth, then off the moon, and back to us. It is a beautiful effect, but it vanishes during the full moon phase. The reason is simple and elegant. When we see the moon as full from our perspective, the moon sees Earth as mostly dark. The geometry flips. Earth is no longer shining brightly on the moon's night side. Moreover, anyway, the sunlit side of the moon is so brilliant that any faint extra light would be drowned out. This creates a lovely symmetry between Earth and the moon. When we see the crescent moon, the moon sees a bright Earth. When we see the full moon, the moon sees a dark Earth. This hidden partnership adds depth to the lunar phases. The full moon looks self-sufficient, but its appearance is still part of a larger dance between two worlds. Even so, the full moon still wins the contest for attention. The full moon can sit beside a bright planet and still outshine it. Planets can be dazzling. Venus can blaze in the twilight. Jupiter can glow with a steady light. Mars can burn with its rusty hue. Yet when the full moon appears in the same region of the sky, the balance shifts immediately. The moon dominates, not because the planets are unimpressive, but because the moon is extraordinarily bright by comparison. This can make for a magnificent sight in the sky. The moon near a bright planet gives the encounter a sense of scale. It reminds us these are not fixed decorations, but independent worlds sharing our view. Even so, the moon commands attention with almost effortless ease. This visual hierarchy tells an important story about distance and reflected light. Some planets are vastly larger than the moon, but they are much farther away, usually appearing as bright points of light rather than broad disks. In contrast, the full moon arrives as a world you can see with texture, its richness and overwhelming light enough to make other worlds look modest beside it. Even Venus, the brightest of them all, can look restrained next to a clean, high full moon. Sometimes, this contrast is unsettling. Venus, near a bright full moon in a clear night sky, suddenly looks restrained, even a little frail. The contrast is shocking because Venus is one of the brightest objects in the sky. It is often called the evening star or morning star because it can shine brightly enough to be mistaken for something more than a planet. In perfect conditions, it can cast shadows and is often the first bright object visible after sunset. But next to a high full moon, Venus suddenly looks restrained, almost subdued. This contrast is striking because Venus is one of the brightest objects in the sky. The moon occupies a different category of existence. It is not a bright point of light. It is a broad disk, detailed enough to reveal markings and overwhelmingly bright. Seeing Venus eclipsed in such company helps calibrate the eye. It shows just how powerful the full moon is. One of the greatest lights in the sky can stand beside it and still look secondary. Beyond planets, the full moon must also contend with atmospheric interference. Near the horizon, the full moon can ripple like a mirage in the heat. When the moon is low, its light passes through thick layers of atmosphere filled with moving pockets of warm and cold air. Those moving layers bend the light slightly in different ways, causing the moon's edge to tremble, ripple, or blur. Above hot ground, roads, rooftops, or desert air, this effect can be particularly striking. The moon may seem to shake, as if reflected in water. It can flatten, stretch, or flicker at the edges. This is the same type of atmospheric distortion that causes terrestrial mirages. It reminds us that the horizon is one of the most dynamic places to watch the moon. The low-hanging full moon is never just the moon. It is the moon filtered through the turbulent lower atmosphere of our own planet. This is why moonrise feels so vivid. The sky is not displaying a static image. It is showing a world through moving air. This turbulence is everywhere. Atmospheric turbulence can make the full moon ripple, sway, or flash with color. Even on a clear night, the air above us is not still. It is filled with moving layers of different temperatures and densities. Each layer bends light slightly differently. When the full moon's light passes through that turbulent air, the bright disk may appear to quiver, wrinkle, or dance at the edges. Sometimes the effect is gentle, sometimes it is dramatic, making the moon look almost liquid. Under stronger turbulence, tiny flashes of color may appear along the edges as the atmosphere briefly splits the light into different hues. This is especially noticeable when the moon is low, but it happens high in the sky too. The sight feels strange because it reminds us the sky is not an empty window. We are always looking through an ocean of moving air. The moon itself remains still in space. The trembling belongs to our atmosphere, turning a solid world into a wavering image, and that is all. However turbulent it gets, the full moon is ultimately a node in a process. The full moon marks a stage in a continuous cycle of motion. It is easy to treat the full moon phase as a destination, as if the moon arrives there and rests. In reality, nothing in the scene is stationary. The moon is orbiting Earth. Earth is rotating. Earth is also orbiting the sun. Meanwhile, the angle between the sun, Earth, and moon changes hourly, meaning the bright round face is just a positional moment in a larger sequence. Before this, the moon was waxing toward fullness. After this, it will wane. This gives the full moon a special kind of beauty. It feels complete, but it is actually a passing position in continuous motion. The moon is not posing for us. We are catching it mid-journey. This idea can make the sky feel more alive. Even the most familiar moonlit night is part of a ceaseless celestial process. The full moon is not a static object in the heavens. It is a moment in motion, looking still only because we are moving with it. This cycle lasts about 29.5 days. The span from one full moon to the next is about 29.5 days. This repeating interval shaped human concepts of time long before clocks and calendars became daily tools. The cycle is long enough to feel substantial, yet short enough to be tracked by the naked eye from month to month. A child can notice it. A farmer can work by it. A community can build traditions around it. This span also explains why the moon drifts through our calendar, never fitting neatly into it. The cycle is not an integer number of days. So the full moon slides through dates and seasons, familiar yet never perfectly fixed. This rhythm has a deep satisfaction. It repeats with astonishing fidelity, yet without mechanical neatness. The moon returns, though never landing on exactly the same page of the month. This slight misalignment is part of its charm. It makes lunar time feel organic, as if it belongs first to the sky, and secondarily to our counting system. Astronomers have given this cycle a scientific name. This repeating span is called the synodic month by astronomers. The phrase sounds technical, but it describes something beautiful and simple. It is the time it takes for the moon to return to the same phase as seen from Earth. For instance, from full moon to full moon. The point is that this is not exactly the same as the time it takes the moon to complete one orbit relative to the distant stars. As Earth moves forward in its orbit around the sun, the moon moves around Earth. So the moon has to travel a little farther to line up with the same phase again. That extra chasing time creates the cycle we notice in daily life. The word synodic gives a precise name to a familiar rhythm that people tracked long before astronomy formalized it. This is the best part of scientific language. It does not replace wonder, it sharpens it. A common sight in the sky turns out to depend on subtle orbital timing hidden behind the everyday word month. This timing is universal. The full moon belongs to no single country, language, or century. Empires rise and fall. Borders shift. Languages branch, merge, and vanish. Yet the full moon continues to return above all of them. People separated by culture, religion, and history have all given it names, assigned meanings, recited poems, issued warnings, built calendars, and prayed. No single tradition can claim ownership of it entirely because it has always existed simultaneously in multiple worlds. This gives the full moon a rare nobility. It belongs to human experience, but not to any single human group. Kings could look up at it, and so could shepherds, prisoners, sailors, or a child in a city apartment. The same bright disk spanned every era and every social boundary. This is why the moon feels larger than mere astronomy. It is also a shared heritage. Long before global communication, people who would never meet lived under the same returning light. The full moon is one of humanity's oldest common references, and it remains so today. This sharing transcends physical distance. People separated by oceans still look up at the same moon. The idea brings an unusual comfort. Two people might live on opposite shores, in different countries, or on different continents, with no common language. Yet when the moon becomes full, both can look up, knowing they are seeing the same object. Not its image, not its symbol, but the actual world hanging in space above Earth. Of course, the moon may rise at different times for them or sit in different parts of the sky, but its identity is shared. This makes the full moon one of the most direct connections between distant human lives. It is a real common point in the sky, important emotionally and practically for thousands of years. Lovers, immigrants, pilgrims, soldiers, and travelers have all taken comfort from the idea that someone far away might be standing under that same light. The moon does not erase distance, but it gives distance a visible bridge. However, perspective determines the image you see. Yet, the full moon looks upside down in the opposite hemisphere of Earth. People often assume the moon has a fixed appearance for everyone, but our viewpoint depends on where we stand on Earth. Observers in the northern and southern hemispheres are looking at the moon from different directions. So, the familiar patterns of dark plains and bright highlands appear rotated. What looks upright in one hemisphere may look inverted in the other. This is not because the moon changed its face, but because we stand on opposite sides of a curved planet, each bringing our own sense of up and down to the sky. Experiencing this effect for the first time, either in a photo or while traveling, can cause a pleasant sense of disorientation. The same moon suddenly looks like a cousin of itself rather than a perfect copy. This variation is a beautiful reminder that stargazing is always, in a sense, local. Even though the object being watched is shared globally, our planet subtly turns the viewpoint into a variation, and the moon reveals this truth. This relativity holds true in space as well. From the moon, when Earth sees a full moon, Earth shows a new Earth. From the reciprocal viewpoint of 2 points in space, the phases of Earth and the moon are mirrors. When we see the moon fully illuminated from Earth, an observer on the near side of the moon would see Earth in the opposite phase, meaning Earth would appear almost dark. Our planet's bright side is mostly turned away from the moon at that moment. This elegantly flips normal intuition. Our bright full moon corresponds to a new Earth in the lunar sky. If you stood there, the land around you would be lit by the sun as seen from Earth, and our own world would hang above, dark, perhaps with only a thin sliver of edgelight. The idea deepens the connection between the two worlds. Lunar phases are not isolated events. They are connected perspectives in a shared geometry. Every phase on one world corresponds to the opposite phase on the other. Astronauts were lucky enough to witness this firsthand. Astronauts saw full Earth from lunar orbit. When we see a new moon, one of the most stunning visual gifts of the space age is seeing Earth rise above the lunar horizon, bright clouds swirling, vibrant against the blackness of space. When astronauts were near the moon and we on Earth saw a new moon, they could look back and see Earth near its full phase. Oceans, weather systems, continents, and white cloud bands turn our planet into a glowing orb, far brighter than the moon appears to us. This inversion is thrilling because it lets us imagine the Earth-Moon relationship from the other side. Lunar phases do not belong only to the moon. Earth has phases too. Seen from lunar orbit, our planet becomes a far more dazzling object. To the astronauts, that sight was not only beautiful but also disturbingly intimate. Home looked whole, hanging in the darkness, while the moon beneath their feet looked barren and silent. Full Earth, seen from lunar space, remains one of the most profound and humbling sights in human history. Ultimately, this connection makes the moon feel eternal. The full moon feels eternal because it links deep space to the ordinary moments of life. This is perhaps its greatest power. The full moon belongs to astronomy, geology, gravity, and deep time. Yet it also belongs to twilight walks, bedroom windows, quiet roads, and the simple act of glancing up after sunset. It is both cosmic and domestic. A world shaped by ancient impacts hangs above clotheslines, rooftops, fields, and sleeping towns. Sunlight crosses space, strikes an airless surface, and returns to illuminate an ordinary human night. Few things connect these scales so effortlessly. The full moon asks almost nothing of us. No telescope, no special training. Yet what it offers is immense. It brings another world into ordinary experience. This is why it feels eternal. Generation after generation meets that same bright face, feeling both the smallness of human life and the strange privilege of it. We live in a place where deep space regularly enters the night and becomes part of the household. Tonight, we have followed the bright path of the full moon across science, history, and human imagination. We explored how that glowing disk is actually sunlight returning from a world of rock and dust. We studied the hidden geometry that creates the full moon phase and how the slow dance between Earth and moon shapes tides, lengthens our days, and slowly pushes the moon farther into space. Along the way, We wandered through moonlit fields, ancient calendars, coral reefs releasing life to the rhythm of the moon, and cultures around the world gathered under the same bright sky. We saw how the moon guides travelers, inspires poets, troubles scientists, and quietly watches over generations who looked up in wonder, just as we did tonight. Perhaps this is the most remarkable thing. The full moon connects deep space to the humble moments of life. It shines on oceans and forests, on cities and quiet roads, on people who may never meet yet share the same light crossing the night. So now, let the journey slow down. Let the images blend into the calm rhythm of the night sky. Picture that pale world rising gently over distant mountains. The air is cool, the earth is still, the moon hangs steady in the dark, and you need do nothing but rest. If you enjoyed this gentle exploration, you are warmly invited to like the video, subscribe to the channel, or share your thoughts in the comments below. It helps other sleepy wanderers find their way here, one by one. If you are still awake, there is another gentle journey waiting for you on the screen. But for now, let the daylight soften and drift away. Sleep well and good night.